Have you ever thought about building your own 3D printer but absolutely no desire to wade through countless individual parts? Then the Voron Trident Kit from Siboor might be just the thing for you. This is an open source printer that has a pretty solid reputation in the maker scene, especially for its flexibility. Okay, I will admit it, at just under 1,200 euros for the 350mm version, it's not exactly a bargain, especially when you consider that the Formboard kit is already available for about 960 euros. But Siboor includes a bunch of modifications. Less tinkering, more fun printing, right? But honestly, is the extra 250 euros really worth it? And a question many beginners ask, is the kit also beginner friendly? Well, we will clarify all this in this video, so stay tuned, it's going to be exciting. In the video you will see scenes both with and without the track chain. The reason for this is that some scenes were recorded later after I upgraded the extruder from Clockwork 2 to Galileo 2. I will explain the specific reasons for this later. Since the mount of the drag chain hasn't yet been attached to the Galileo 2, the CAN cable is not fixed and hangs freely. However, for all the test prints I used the Clockwork 2 to ensure that the results match those you achieved with your printers. As already mentioned, Siboor provided us with this kit for testing. You can find the link to the product in the video description down below. This is the so-called first batch, so the first version. Early versions of 3D printing kits often still have a few problems, but hey, that's often where you get decent discounts for. For example, Siboor included free upgrades for the first 100 buyers, such as TMC 5160 drivers instead of the 2240, titanium backers for more stability, and extra corner brackets. We have been in close contact with Siboor over the past 3 months, regularly exchanging ideas on their Discord server to quickly resolve these minor issues. More on that later in the video. What you should know about Siboor: they are a relatively new provider of hardware kits, specializing in making open source projects like the Voron or the ERCF more accessible. They pack all the necessary components into a complete package and send it directly to you, similar to Feistek. They have made a significant leap with the ERCF V2 kit, which includes their own modifications such as a pre-installed AWDs and a board with micro switches. Let's turn to the main topic, the Voron Trident. This is a kit with a print bed size of 350mm. The Voron itself is the result of an international tinkerers consortium that has designed several 3D printers. The most well-known is probably the Voron 2.4. However, if you need a smaller print bed, there's the Voron 0.1. You can find the test for it in the video description or at the top in the info box. The Voron Trident is a Core XY printer with a fixed gantry. Unlike the Voron 2.4, where the bed is stationary and the gantry moves in flight, here the print bed moves in the Z-axis, similar to the Creality K1 or the Bamboo X1C and P1S. The advantage of this design: the position of the print nozzle in Z always remains the same, which facilitates the integration of additional cooling. Moreover, the Trident is easier to build and maintain than the Voron 2.4. The latter uses this flying gantry, which really requires precision during assembly and fine-tuning. Particularly the belt tension of the 4 C belts is a stumbling block for many beginners. You won't have this problem with the Trident. A huge advantage of the Voron printers are the really good instructions from the Voron team. They are like a mix of IKEA and Lego build instructions, which detail step-by-step pictures and clear information about the individual components. Compared to our last video, where we could only assemble the LH Stinger using a cut drawing, this is truly a blessing. You are guided through the entire building process, which is especially helpful for beginners. If you need more information about the Trident, just check out the Voron Discord or their website. As previously mentioned, the Siboor team has come up with a few cool modifications for the Voron Trident kit, which I would like to introduce to you now. Normally, a Voron consists of many 3D printed parts that you must print yourself or obtain from third parties. This can lead to problems if these parts do not exactly meet the specifications, which can later affect precision. Siboor takes no chances and replaces most of the mechanically stressed 3D printed parts with CNC manufactured parts. Even though this contradicts the rep concept, I'm a big fan of it. If something goes wrong, I have one less error to look for because CNC parts always meet the exact tolerances. However, be careful. If you want to upgrade the CNC parts yourself, choose those that are adapted for CNC and not just remilled. In this kit, the CNC parts are perfectly adapted from the start on. Yes, you heard right, the Trident has a kind of a refrigerator door. Instead of the usual acrylic plates, Siboor has installed an airtight door with an additional frame. This ensures that the temperature in the print room remains constant, especially important when you are printing with filaments like ABS or ASA, which require stable temperatures. Furthermore, no odors or vapors escape from the print room. For me, this has become an absolute must-have, even with the Voron 2.4. Normally, the electronics in the Voron 2.4 and Trident are installed under the printer. This is fine until you need to make an upgrade or replace something. Tilting or turning over a 350mm printer is not easy. Siboor has cleverly solved this with the Invert Electronics Bay mod. The electronics remain below but are now accessible from above. No more tipping required. An intermediate plate protects the electronics during normal operation, and maintenance or upgrades are so much easier. Normally, the Core XY drive in the Voron is operated with 2 motors. The problem, often only one motor takes the main load. With the AWD mod, Siboor installs 4 motors, 2 per axis. This relieves the motors and allows higher speed and accelerations. I will tell you about the possible disadvantages of this later in the video. Precise printing depends on the printer knowing where the print bed is located. With large aluminum print beds, the material can expand when heated, which can quickly lead to problems in 3D printing. A height difference of just 0.5mm can completely ruin your print result. Siboor relies on an eddy current sensor, which automatically creates a bed mesh and compensates for the height difference. This makes the first layer perfect, and you don't have to set it manually. Because the Trident is designed for high printing speeds, thanks to the installed Fides Rapido 2.0 Pro Ultra High Flow hot end, it also needs good cooling. The Voron printhead Stealth Burner standardly has only a 50-15 fan, which quickly reaches its limits with fast PLA prints. Therefore, Siboor has installed a 120mm radial fan that is mounted externally and blows directly onto the print object. Advantage: the weight of the printhead remains low and the fan is quieter because it needs fewer revolutions for the same amount of air. Instead of the usual 2020 aluminum profiles, Siboor uses a carbon axis for the X-axis. This significantly reduces the weight, which especially makes a difference with a large printer like the Trident. Less weight means fewer vibrations, thus higher speed and acceleration. Moreover, there's a filter pack with activated carbon that filters the indoor air, ensuring that fewer harmful vapors and fine dust end up in your workspace, especially important when you work with the filaments like ABS. As for the motors, Siboor uses 2240 drivers that are actively cooled. 2 40-10mm fans blow directly onto the main board to optimally cool the drivers. The motors have a longer shaft, which is additionally stabilized by a ball bearing at the end. This prevents the shaft from bending under high belt tension. Finally, the kit includes a Big3Tech HDMI 5 display with clipper screen. This makes controlling and setting up the printer super easy. The printhead is connected via CAN, and Siboor includes a Big3Tech EBB SB2209 CAN board. And no worries about the Raspberry Pi. The kit includes the CB2, the Big3Tech CM4 variant, along with the Manta board, so you have everything you need on one board and don't need an additional Pi or other MCU. Here again are all the technical data and overview. Feel free to pause the video if you want to look at the details. As already mentioned, the instructions for Voron printers are truly first class. However, it can get complicated if you want to include modifications directly during assembly. To facilitate this, Siboor has developed a completely new guide that consists all the mods. This was a huge challenge, and a few small errors crept in at the beginning, like incorrect screw length or part designations. But no stress, we reported these errors on Discord, and within 24 hours they were corrected in the instructions. I'm sure that there are no more errors now. The assembly itself is no problem with these instructions and a bit of technical skill. But be careful, with this printer you also work with electronics that use mains voltage. The power supplies here are not separately enclosed like in a laptop, but are openly installed. Especially the 1000 watts heating bed runs on 220 volts and really only an electrical technician should connect this. If you do not have this qualification, it is better to ask someone who can help. With 24 volts low voltage, it's not so serious, but here you can seriously endanger yourself if you accidentally put the frame under voltage. Even with such a well thought out kit as the Voron Trident, there are a few weaknesses that I noticed during assembly. Let's go through them. I had problems with the belt tensioners on the X and Y axis. Even during assembly, I noticed that the carriage was not moving smoothly. After a brief conversation with Siboor, the problem became clear. The parts were CNC manufactured with exact tolerances and then anodized. These additional layer, both in the groove and in the slot, changed the tolerances so the carriage jammed. But Siboor quickly solved the problem. They adjusted the production and sent me new belt tensioners and AB mounts for free, which now work perfectly. In my opinion, the installed stepper motors are significantly louder than those from LDO or Stepper Online. But keep in mind that twice as many motors are installed here, so the operation is generally louder. The first batch also had problems with clicking pulleys. The community suspects that the tolerance between the pulley and shaft is too high, so pulley has some play. This is not a problem for print quality, but the noise can be annoying. Siboor fixed the problem with the new O-shaft motors. If you hear the clicking, you can reduce the belt tension or use pouch pulleys, which the community says fit perfectly. There were also problems with Siboor's own branded T15 fans. Siboor drove them from the usual 6,500 to 8,000 revolutions per minute, probably too much of a good thing, as the first fans broke down after a few days. Here too, Siboor reacted super fast. They adjusted the production and I was sent new fans for free. That's what I call customer service. And if you think this happened only because of my reviews, don't worry, private buyers received the replacement components as well. A general problem remains the noise. It's okay for the component cooling because a lot of air has to pass through, but the controller fans and the driver's fans are really loud. If you are sensitive to noise, you should consider replacing them. My man, as mentioned, the print head here runs over a 4-wire CAN cable, which is also included. The problem, it is sleeved and the sleeve does not fit into the groove of the aluminum extrusion. So you have to remove the sleeve without damaging the wires, which can easily take half an hour. If you cut too deep, you can throw away the cable, so please be careful. If you manage to remove the sleeve, you will see that 2 of the wires are twisted. This is normal, definitely leave them that way. Bit background for that, in symmetric signal transmission, an external disturbance affects both lines equally. The electric fields in the wires are exactly opposite, and so are the resulting magnetic fields around the wires. When the 2 wires are laid closely snuggled together, the magnetic fields cancel each other out, also completely eliminating the emission. This is known as twisted pairs. Another problem in the first batch was the cable length. They didn't always fit, but it was also fixed in August. Now the cables are long enough. A small disadvantage is shown in the combination of external component cooling and the invert electronic bay mod. The cooling partially blocks the intermediate floor of the electronics bay, so you have to fiddle a bit to remove the cover. But I have a little technique. If you tilt the intermediate floor correctly, it stays in the position by itself without having to hold it up. Here, Siboor really can't be blamed. In one batch of the Rabbit 2, there was a flaw in the heater block that caused the temperatures to be read incorrectly. The temperature offset can be up to 50 degrees in some cases. These faulty blocks appeared both in generally sales and probably in a delivery from Fetus to Siboor. So if you suddenly notice errors while printing, for example that your PLA suddenly shows extreme stringing at the same temperatures as usual, then you might have caught a faulty heater block. But don't panic, I assume that Siboor is aware of the problem by now and the kits that are now being sold no longer have faulty heater blocks. If that is the case, you can contact marketing at fetus.com directly. Include your Siboor order number in the email and briefly describe the problem. You will then receive a replacement block for free. All in all, these are the major flaws I noticed during assembly. Sure, you shouldn't have to replace so many parts in a kit, but keep in mind, even if the price seems high, the kit is still a bargain compared to the individual components. If we go through the parts, that almost adds up to the purchase price of the kit, meaning motors, fans, power supplies, cables, pulleys, and bearings are partially a free add-on. And if you want to replace a few parts at this price, it's bearable for me. Once you have completed the assembly, I strongly recommend going through the Siboor setup guide. This guide explains the initial important tests and shows how to properly set up the slicer and clipper. There are some really useful tuning guides available now that will help you get the most out of your printer. For example, regarding belt tension and other nuances. This guide is really a great foundation to ensure that your printer is running optimally and you are getting the best out of your setup. Many of you are probably already familiar with Clipper, so I will keep this brief. For those who are new to it, you will find a linked video in the info box that explains the basics. But now I want to discuss a few special features. When you get the Siboor kit and turn it on, you will probably find that some components do not have the latest firmware. The Siboor 2 module can be updated without any problems, but the clipper might initially refuse to work. Because the motherboard, the EBB toolhead board and the cartographer also need to be brought to the same firmware version. If you have trouble updating, just check out the Siboor GitHub where the steps are well explained. For flashing the cartographer module, there's even an adapter cable included by Siboor, so you can update it directly via the PC. You can also find the appropriate configuration files on the GitHub. The link is in the description. The configs still have some optimization potential, especially with the PWM control of the fans. At certain speeds, they give off an annoying hum. On your own GitHub, link in the description, you will find optimized configs that fix the problem. Keep in mind that you need a few plugins for the configurations to function correctly. We will clarify which plugins those are shortly. If you have an AWD setup with 2 motors per belt, you can't just start up, the motors first need to be synchronized. To facilitate this, Siboor has changed the shaft from D to O for manual synchronization. I recommend the tutorial from WeCBot, where it is explained step by step how to synchronize the motors by loosening the set screws on the pulleys. Keep in mind that this synchronization can be lost if there is a step loss in the motor. This can even happen when you turn off the printer. To circumvent this problem, I use the AutoSync plugin. You can find information about it on the plugin's GitHub and the link is in the description. With the plugin, you can automatically synchronize the motors by inserting a command in the start code. The print head is then moved, one motor is deactivated, and the synchronization is checked. If the motors are not synchronized, one of the motors will jump back and the resulting vibration is detected by the ADXL sensor on the cartographer. The plugin then adjusts the motor in small steps until the vibration is gone, and you can even hear this. After this test, the motors are synchronized and you get a much better print quality. Particularly, ringing and ghosting are greatly reduced and the motor temperature also decreases. Now, let's get to the heart of the review, the print quality. I want to preface this by saying that this is my personal experience and other users, especially in the 3D printing community, may have different results. I had to limit the flow to 15 cubic millimeters per second, even though the printer is actually designed for higher speeds. Why? This is due to the installed Clockwork 2 extruder in the Stealth burner. The CW2 is a DIY extruder made from printed parts that uses the BMG kit for mechanical drive. The setup is adjusted via 2 set screws, which ensure that the filament is fed cleanly without overheating the motor. Many in the community have been using this extruder for thousands of hours without any problems. But for me personally, and I emphasize this, the Clockwork 2 has never functioned as it should. Since the beginning of my 3D printing journey, the CW2 has unfortunately only been a negative experience. Others in our community share this experience, stating that it tends to be finicky, especially at higher flow rates over 15 cubic millimeters per second. My problem? Either the filament slipped or the stepper motor skipped, meaning that the gear on the motor shaft did not turn properly despite the impulse being there. Initially, I thought this might be due to poorly printed parts, but after testing parts from various community members that were visually perfect, the problem persisted. Many also say that the CW2 is more prone to such issues without the original BMG extruder kits, for example the gears and bearings. Therefore, I have replaced the Clockwork 2 with the Orbiter 2 or Galileo 2 in all my printers. However, for this review, I retained the original hardware but had to reduce the printing speed accordingly. With the flow limitation, I can reach up to 250 mm per second for common print objects with an acceleration of 20,000 mm per square second and an SCV of 25 mm per second. After the review, I will also retrofit the Stealth burner with a different extruder and update you on how my Trident performs at higher print speeds, over 350 mm per second and flow rates over 15 cubic millimeters per second. But again, many Trident owners have no issues with the CW2 and I do not want to disparage this setup. For my review, however, I could not just adjust the CW2 to work for the possible high speeds of this AWD printer. To rule out a potential problem with the heater block of the Rapido 2, I first printed a temp tower. If you don't know what that is, a temp tower consists of several stacked segments that are printed at different temperatures. The temperature is gradually lowered from segment to segment. The goal? To determine at which temperature the print quality is optimal. When testing, I pay particularly attention to bridging, overhangs and general surface quality. If several segments look equally good, a break test helps. Here, for example, you can try to break off the tip of a ring with the Allen key, or completely break apart the segment. Where it is hardest to break something, you usually find the ideal temperature. This temperature is then stored in the filament settings in the slicer. The temp tower I printed ranged from 240 degrees to 190 degrees. The results were interesting. Clean printing was no longer possible below 200 degrees. At 230 degrees there was significant stringing, but at 220 degrees, despite a small error at the front bridge caused by the too strong airflow from the aux fan, the result was quite good. At 215 degrees it was particularly difficult to break the tip in the ring. Therefore I have set this temperature as optimal in the slicer. By the way, this value corresponds to the manufacturer's specification of the filament, which suggests that the thermistor of the Rapido 2 is working correctly. I suspect that the filament has absorbed moisture. It had been stored open for years. So this could explain the stringing. I will verify this assumption in my next test. Similar to the review of the LH Stinger, I used the dodecahedron test to assess the quality of overhangs and retracts. At first glance, the printed object looks good. However, it is heavily affected by stringing, fine, loose filament threads. This suggests that the filament has absorbed too much moisture. For upcoming tests, I have therefore changed the filament to achieve more precise results. Tests as in my LH Stinger review, check out the last video on our channel, I also printed the clearance test here. This is a kind of a fidget spinner that features print-in-place joints with different gaps. This object is great for checking the dimensional accuracy of the printer. As you can see, all elements move well and are not welded together. Also, the layer stacking is really good. Apart from ringing, the surface is nice and smooth. This is because at this point I had not yet optimized the input shaper. Especially with AWD setup with two motors, if the setup is not perfect, the resonances can be transmitted through the belts or the CNC gantry to the hot end and ultimately to the print part. With a full metal gantry, these vibrations are also less damped than with printed parts. Therefore, I highly recommend you check out the Shake Tune plugin from Fricks. With this plugin, you can not only optimize the input shaper but also synchronize the belt tension and even perform tests depending on your speed. This allows you to see exactly at which speeds, even with input shaper, the vibrations are strongly pronounced. Then make sure that you stay outside these vibration zones when slicing. If you can't make the head or tail of these charts and would like us to make a video explaining the plugin and its function, let us know in the comments. To test the manifestation of ringing, printing the Orca cube is excellent. The X and Y letters on the model make ringing and ghosting clearly visible, as is the case here. After optimizing the input shaper, I printed the Voron cube again. The results clearly shows a reduction of ringing and a significant increase in quality, especially compared to the previously used orange filaments. This conclusively shows that the problems were less due to the printer settings or the printer itself, but rather to the filament. For all cosplay enthusiasts, armor is always indispensable. Particularly this type of print object usually requires a generous print area. For my test, I tried printing chainmail. This print poses high demands. Precise bed mesh is essential as well as optimally retract, as here almost exclusively individual points are printed in the middle of the object. The results thrilled me. The chainmail is fully flexible, adjusts perfectly in all directions and fits snugly to the ground. An impressive proof of the possibilities of precise printing. The Voron Trident is an impressive printer for those who enjoy tinkering and building themselves. Developed by the Voron team, this printer clearly targets an audience that brings craftsmanship, electronics knowledge and experience with setting up components on the clipper. Comparing it to plug-and-play printers like those from Bamboo Lab would be inappropriate here, as those targets a different audience, users who want to have good results immediately without prior knowledge. Such printers currently do not offer as large print areas as the Trident. For anyone considering building a Voron, the Trident is an excellent choice for getting started. As mentioned, it is easier to assemble and set up than the Voron 2.4, making it particularly attractive to newcomers. However, those who do not bring enthusiasm for the building process and wish to use the printer commercially should know that DIY printers require intensive care and regular maintenance to work consistently reliable. For passionate makers, however, the Trident is a real highlight and worthwhile investment in the world of 3D printing. Despite the teething problems mentioned in the video, this printer is a real highlight. With double installed motors, mechanical parts made almost exclusively from metal and variety of mods, it offers plenty of room to gradually explore the limits of the printer. Particularly noteworthy is the thoughtfully designed electronics. They are easily accessible and allow for simple maintenance. The support from Siboor is outstanding and significantly stands out from the typical first-level support other manufacturers. Professional support is available via Discord, and Siboor responds quickly and reliable even outside the platform. For the future, I hope that the teething problems of the first batch will be further reduced and that Siboor will continue to place great value on the quality of the components. With this approach, they can clearly distinguish themselves from the other providers. I'm excited to see what developments await us in 2025. As mentioned at the beginning, the extruder was upgraded to a Galileo 2 after testing to achieve higher speeds and more stable flow rates. Some test prints have already been made, including a vase and a VFA test with speeds ranging from 40 mm per second to 400 mm per second at a maximum flow rate of 40 cubic millimeters per second. Here's a sneak peek at those results. Are you curious about these tests turned out? Let us know in the comments. I hope you enjoyed this XXL video. If you're interested in more videos in this style, please let us know in the comments. If you have any specific ideas or content wishes that we should tackle, please share them with us. We look forward to your suggestions. Thank you for watching. Subscribe to our channel so you don't miss any upcoming videos. We will see you next time. Bye bye.